Okay. All right. Hey, we got a couple problems to go through today. Depends on how many you need. My goal, minimum, to go through 2 problems. I have a maximum of 4 if we need to go through all 4 problems today. Today's stuff is based on the tables. So your problem today will be draw your table and draw like the graph, the mock graph of what this table presents. And then you're going to submit your picture on Google Form today. So that's a little bit different than normal. Usually it's like a short answer, give me the critical points. But today you're going to submit a graph to me. Now you don't have to put it on an actual graph back there. It can just be free floating. Just give me a rough idea what you think the picture is going to look like, depending on what this table is going to give you. Okay? All right. All right. Just going to wait some people out here.
We're good.
All right. Okay, let's start with the table here. All right, so this is one of the 4 problems I picked out. If we need to go through another one, we will. I kind of have just a select few picked out. So on this particular problem here, what we're actually going to be doing is trying to make a graph. This looks a lot like your Google question of the day today. It'll be one of these. It'll say, graph the following. That's all it will say. It'll have, this information. So on this one, we have 3 potential x's, actually 5 potential x's, because the second derivatives has a couple weird points. But we have an x1, an x2, an x3. That's where the derivative is hitting 0. So that's either a peak or valley or some point where it changes directions. We have slope being negative on the left side. It actually hits, it changes directions in the middle, and then it's going to positive on the right side. So, so right now, just as it sits, here's what I'm thinking. We have 3 spots where it's going to be 3 spots where the slope hits 0. So we have negative slope. It hits 0. It stays negative for a while. It turns positive, and then it goes up and it changes direction. So currently, I know that's a terrible looking drawing, but this is what I'm thinking of. Now I haven't done my second derivative to confirm like this is what my graph looks like.
So would that be symmetric?
Yeah, that's what I'm thinking of. I'm thinking it could be symmetrical looking. I don't know if it's right over the y-axis, so technically it would be symmetric or not, but the idea is that's what I'm thinking. Now, that's just going off of these things right here. The derivative hit 0 3 times. On the left side, all my slopes were negative. These are all negatives over here for slope. And on the other side, all my slopes were positive. And now, I don't know if this is true, but I'm going to go to the second derivative and confirm it. Okay, second derivative. It's concave up. So I'm going to try to color code this as best as possible. Shh. Okay, so on the left side of this x1, here's x1. This is x2, and this is x3, and let's get rid of that. All right, let's call this x3 or x1 here. All right, so we have my 3 x's. So on the left side, it's concave up. So concave up, we're good there. It's concave down after this point. That's good. Halfway through it, looks like it's like halfway. It's changing to concave up, which it actually is doing, because this thing is concave up. Then it switches again halfway to concave down up to x3, because that was negative. The second derivative is less than 0, so it's concave down. And then after that, it went concave up. So there you go. There's that's actually the drawing. Okay, let me get rid of all these marks so you can see. So what I'm looking for today on your Google question of the day, I'm looking for the drawing that kind of looks like this blue thing up here in the corner.
How do we draw on?
So you're going to draw on a piece of paper, take a picture, and submit it to me. That's what you're going to do. Okay, I saw a hand. Who had a hand up?
I did.
Okay.
So the first derivative is the part you draw with the slopes.
Yeah, so that's how I get my image in my head first. But then there might be a couple things where I need to like modify it maybe.
And then the second derivative is your
concavity. So that tells me if I need to like bow that thing outwards or inwards. So like the second derivative helps me like kind of like fix a few things to make sure the drawing fits. So I go off of first derivative first and just get an idea of what it's doing. Okay? All right, question. I thought I saw another hand up. Okay, now.
It was me, but
Do you want to do another one?
no,
Okay.
it makes sense.
I can read
They don't get easier.
Oh, jeez.
My next one just gets more difficult, I think.
Let's do that.
Next one? Okay. All right. Okay, so the next one.
Oh, God.
Okay, so same thing as before. We have two x's on this one. We have slope going positive, it goes negative, it goes positive, or sorry, it stays negative. So it's probably doing something like, so if I'm thinking about this, it's, okay, so the slope is positive, it suddenly hits 0, it turns negative, and then it stays negative. So, again, this is x1.
Ward, what color tells you the green lines?
What?
What color tells you the green lines?
Blue.
Okay.
Yeah, the blue is what I'm going off of.
Alright.
The x1 and x2 helps me figure out like how many turning points I'm probably going to have, or how many spots it either hits a peak or valley, or how many times it like level off. So that's what I'm using x1 and white and x1 and x2.
Level off?
Right?
What?
The purple tells you.
Yeah. Yeah. What? What was the question though?
Will you explain the middle part again? Why does it level off?
Because on this part, if you look at this region right here,
Yeah.
the slope stayed negative. It stayed less than 0 over that band.
Why doesn't it just keep going down there?
It keeps going, but the problem is, it does keep going. It keeps decreasing, but the thing is, it did actually have a 0 there. So I mean, it had to flatten out, right? So it had to flatten out just a hair, and then it had to keep going down. That's probably what happened. So that's going off of this part right here. It didn't go back up.
So each one of them, you have to have a 0 slope, like when we found our whatever.
So if
thing
it's a
was.
0, kind of just make a shelf? with-
Yeah, exactly. You make a shelf or a hilltop or a valley, and then you just use the blue part to figure out, going up or down.
No.
So
I'll
We're looking
explain
at
it.
like the blue part, so it's like y is greater than 0.
yeah, so that's
So it's
increasing.
going up,
Yep.
And then less than.
Less goes
Go
down.
back
Yeah.
to the last one for a second.
Yeah.
I kind of want to try to figure out what was going on.
Yeah. So am I looking at the,
So the yellow part was telling me like how to draw that thing.
Why is there only
So-
2 though? Why is there
Yeah,
not like
why is
four?
it-
Well, because it was continuing, because there's 3 x's, right? But it was continuing to be negative up through the x2. So up through x2, it was staying negative. It was dropping.
And then it goes right back.
And then it was going up because the rest of the time the slope was positive, so it was increasing. But there was 3 x's
3.
because it had to have some shelves in there because there's 3 spots where it kind of leveled off to 0.
So what does the blue mean?
The blue tells me, in this case, the blue on those tell me that there had to be a peak or a valley or a shelf, like a leveled off spot. So there's 3 locations where
oh,
we
it's
hit
the bottom
zeros.
crap. What is that? What's all the
Yeah.
bottom stuff
The
for?
second-
Now that's second derivative. That helps me with concavity. That helps me if it's like bowing upwards like a cup, or if it's bowing
We're
downwards.
not focusing on that yet.
So we're saying at x1 it bows,
Was
Yep.
that whole table there?
x2 it bows, and x3 it bows. Like so it's like a cup.
Yeah, yeah. So.
Why do you read it like that?
Because the x's just help me figure out where the main locations are on the graph.
Okay, I get
But then I use slope and second derivative, like first derivative and second derivative, to help me figure out the curving of the lines, where they're going. That's all I use it to refine the graph a little bit, to put the little details in there.
So if it's greater than 0, it's the up. It's the
Yeah, on first
cold
derivatives.
water. If it's
Yep.
less,
Yep.
then it's pouring.
It's
water.
pouring the water out. So like in this point, up through x1, it was holding water.
Yep.
Through so up to x4, so that was like halfway between x1 and x2, it was pouring out water.
Because it's less than 0.
Because it was less than 0, so it's pouring out water.
And then it's,
And then
holding
it's
water.
going up through x5 here, so it's holding water.
Wait, why is
And then
it
it
holding
pours
water?
out, and then it pulls
Oh, wait,
water.
never mind.
Do you want me to?
I think I can.
Question?
Oh my gosh.
Okay, so for the blue, would you ever give us a point where it doesn't line up with x1 or x2 or x3?
Probably not.
Would they ever do that in like?
I haven't seen one. I've never had to do one.
How would you even draw it? Oh, or
I don't know. I've never.
just don't know.
I don't know.
Would it give you just a
Let's
different
not
point?
confuse ourselves.
Let's think about this. I want to know.
Would you
What
just
about
do like
the
an extra point? Like if they said like X point.
You think you just go through it? It's zero.
I think we should not confuse ourselves.
I started doing that. And I put
I don't know.
Right there.
I bet it goes right through, like it'll.
It would just have to pass through, I guess. Maybe that's how they would, maybe that's how they could get you to have very specific points to say like X, 3 would be 17. So then you could be more exact on the graph.
So would it screw up pass through? Would it screw up your concavity of it?
No, I wouldn't even think about concavity at that point. The second derivative just helps me with
It would
concavity.
have to fall on the left.
Yeah, because I'm not really focused on details. I'm just getting like the curves right.
So that basically gives you more detail on like
Yeah.
to where to.
Yeah, exactly. Okay, all right.
Didn't you say it's impossible? You say it's coming down, right? And then you say, oh, it doesn't equal 0, it equals 2 at this point. So then it has a sharp line up.
Yeah. Yeah, so if the slope was 2, it would be like a really jagged line. It'd be just it'd be like a diagonal. And that technically wouldn't be a 0 at that point then. Yeah. Okay, so at this point, this is that second one that we were just finishing. It was concave down. That made sense all the way up to x1. It's concave up at this point.
There's your shelf.
No, that's.
And so I'll have to fix this. So it's it is actually concave up because
You have it right. You
yeah,
don't
it's
have
bowing like that. So it is concave up
And then down.
and then down again. Yeah, this is a little bit
It
messy
should
in
be a little
here.
more divot.
Yeah, it's a little bit messy.
Wait, what are you
So.
talking about?
This is the second derivative is concave down. Then it's being concave up.
It should be a little deeper.
Okay,
And then it
I
should be
understand
concave
the
down.
first one.
Now I'm using the second derivative to make sure my curves are right. I think that's about right. It's close enough that I'll give it to you. Okay. Fine. Fine.
You know the Disney, like,
Yeah.
you need to find the slope of that mountain.
I'd take like 50.
Okay. Moving on. So, okay. Last problem today. This is my last one, absolute last problem of the day, and then I'll turn you loose. Now, your homework today, or not homework, but Google question of the day is based on the table stuff. You have to take a picture of your drawing, what you think the drawing is supposed to look like. This is the stuff we're going to be doing probably more on Monday. Because remember, we're getting an actual assignment on Monday, where it's due later in the week. It's several problems where you have to find first derivatives, like critical points, all that good stuff. Let's walk through this particular problem. So just to see what it is, because I haven't actually done this one yet. This one I found in the book. I kind of want to know what it was.
Is that
So, as x, that is 3x to the 1/3, and then it's minus x in the back.
so it's not attached to the one?
No, it's not attached to the 1/3.
I want to taste it.
Okay, so on the first derivative of this thing, okay, so first derivative, we'll drop the power out front. We'll subtract 1 off the power, and then for the x in the back, it's just minus 1 because you drop the 1 out front and subtract 1 off of it. So it'd be a negative 1 x to the 0, which the x to the 0 would go away. So this is the first derivative. I'll clean this up here in a second. So I just did power rule. Drop the power out front, subtract 1 off the power, and then the negative 1 in the back. So yeah, so if I clean this up a little bit, the 1/3 times 3 is 1, like you said. I don't even need to add the 1 there. And then subtracting the powers, 1 is 1 over 1, which is actually 3 over 3, because I have to get common denominators. I subtract to get a negative 2/3. And so this is just simplifying the first derivative. And if I actually move things around here, what is this actually turning out to be? It's a radical on the bottom. It's a 1/3 radical. So this ends up being a 1 over the cube root of x squared on the bottom.
Do we have to do that?
No, I'm trying to figure out what it looks like so I can get a sense for what that
Where
thing
does
is.
the negative go? Oh, never mind. You switched it.
Yeah, I just moved it to the bottom.
Why is it x squared?
The on the top of the fraction, when you have a fraction of power, the top number is your power, the bottom number is the radical that you're using. And it's negative, so it's on the bottom of the fraction bar. That's all it is. Now, you don't need to do that. I could have left it.
Simplified even farther.
Yeah, I wanted to see what this thing actually looks like simplified. I don't like fractional powers unless I can see what it is. This is just for my purpose, this part in blue. Just get a sense for this thing. Like, when you do square roots, I can't plug in negative numbers into that thing. because it won't work. Because you can't take, actually you can take a cube root, couldn't you? Cube roots you can take negative, so that's why it's allowing me to go to -1. Okay, all right,
Why are you asking me?
What? He's talking to himself.
all right,
Weren't you?
yeah.
Why are you asking me?
I'm not asking you.
You said I
All
was
right.
supposed to be an algebra 2.
Algebra
Oh my
1.
God. All right,
That was just a straight up burn. You can't be salty about that. That was just.
Oh,
you asked me to do one,
I am.
so I didn't do any more. I figured you'd cry. All right, moving on. Sorry. I probably should stop before I get fired. I like my job. All right, let's move on. All right, so we're gonna go from what?
You're out $10.
Don't care. All right. So it's not like I use that thing. All right. So okay. Figure out the critical points here. We'd have to figure out where this thing would equal 0. So if I were to set this thing equal to 0, just to figure out, what would make this thing work. Sorry, what? I'm going to set this thing equal to 0, add the 1 across. This is actually figuring out critical points now. So again, this is to find critical points. So just I'll label this. This is the only reason why I'm doing this. To find critical points, I'll add the 1 across to the 0. And I'll multiply the bottom item over to the other side to get it off the bottom of the fraction. Take the cube root, take it over to the other side, cube that number.
Oh God.
Oh,
There's
wait,
a
hold on.
lot of reversing.
Yeah, it's a lot of, it's just a lot of like inverse operations. And then take the square root of that number. So 1 to the 3rd power is 1. I take the square root to the other side, and it's plus or minus the square root of 1.
Wait, so you subtracted the 1 over and then multiplied the...
So it's plus or minus
So
1.
it's...
So I added the 1 across, right?
Yeah.
Add this 1 across. Multiply the denominator over to the 1.
So the 1 just goes away.
Yep. And then I took instead of this power here, this cube root, I took it and did the opposite of a cube root, which is a cube. Then I took the square root to get rid of that power 2 off. And it ends up being plus or minus square root of 1, which is plus or minus 1. So I actually have a couple critical points. One of the critical points is the end point of my thing, and the other critical point is in between. So if I was using my little table set that we talked about last, I guess yesterday, I have -1 over here, I have a critical point of 1 in the middle, and I have 8 as my boundary over here. So what I'm going to do is plug each of these numbers in, and then figure out what the values are to see if it's a max or min, if it's an absolute or if it's relative, or what the book calls local or global. I like absolute and relatives. I like those words better. So I'll plug these numbers in, and remember, when I plug the -1, the 1, and the 8, how I'm getting these numbers, again, I'm using the numbers from the critical points, these, and I'm using the original numbers on the problem that they gave me limits on. On this one, I can actually use them. I know the Google question of the day yesterday, you were not allowed to use the end caps. So you had to put them on the picture, but you couldn't use them as a max or min. So you were not allowed to use them.
Why?
Because they didn't have the bars underneath them. So you weren't allowed to use the end caps. On this one I am. I can include those as values.
Because
It was just
equal to or...
Yeah, it's greater than or equal to or less than or equal to. Yeah.
Sits on that.
Yeah.
I didn't even think of... Okay.
Yeah.
I got it.
So, and the only reason why I want to include them is just to see, maybe, because the only reason why I would include those end caps, even though, maybe there wasn't the bar underneath it, is just to see kind of where that graph's going, because maybe that point on the ends are so high, it's above what you thought was supposed to be a maximum. But that, end cap went up, and it went higher than that. So that would tell you it would have been a relative, not a global.
Dude, your girlfriend?
So.
The girl you were kissing her in the face? I was like, wow. I didn't suck your nose.
Yeah.
Okay. Hey. Okay, hey. Can we focus on some math here? Don't know what we're doing here. So,
Yo, somebody send me the link to that.
hey, let's focus. All right, so I'm going to plug in the -1 now. I'm going to plug these numbers in. Hey, I'm going to plug these numbers into the original function to figure out the values. So when I plug in a -1 into my original function, -1 to the 3rd power is -1. times, so I'm plugging these, I'm just going to do it in a calculator. I don't even want to do this in my head.
You're
So,
plugging into the first, the f of x, right?
Can't say I've been there.
all right, minus -1. So I'm plugging these into the original function to figure out what the values are right now, not first derivatives yet. So again, I'm plugging these numbers in here because I need to figure out what the values are, because the whole question that we did yesterday was max and mins. So I'm plugging them into the original function. So when I plug a -1 into that mess, it ended up being a -2. The next number I'm going to plug in the same formula. I'm going to plug in a +1 now. Somebody have a question? If I plug in a 1, I get 2 out of that formula. Again,
The -2, I don't know how you're plugging this in here.
I'm plugging into that part up there.
Yeah, but I don't know what I typed in.
I don't have enough room for this. All right. 3 -1 to the third power minus -1.
Yeah, I did.
1/3.
1/3. This is a cube root.
So it's +1.
So cube root of a -1 is, or cube root of a -1 is -1
Okay, got it.
times 3, and then this is +1 because
Yeah, got it.
that makes it +1. So it ended up being -2.
Who's, is that like,
Type it in wrong.
whose record is that?
Girl.
No, it's not.
Yeah, it is.
No.
They lost one.
That's JV record. I was going through JV record today trying to figure it out. Okay, all right. 8. So if I plug in an 8 for this next part here, to figure out that, if I plug in an 8, let's go back up. Plugging in an 8 into my original problem, I'm getting a -2 again. So it looks like on this particular problem, I have two minimums. They happen to be absolute minimums, and then the middle is a maximum. So this ends up being the max. These end up being minimums. Now there happen to be 2 minimums, so I know they're both absolute minimums. There's nothing that went lower than that because I don't have any other critical points where it changed directions. So you can call them relatives, you can call them absolutes. It doesn't really matter. There's 2 of them, so I can understand why you call them relatives. Yeah, just call them minimums. The maximum is an absolute. We know that, or global. That's what the book refers to it as. Now,
It's a max because the y number is bigger.
yeah, the y number is bigger. So it's the highest point on that graph currently. Now, if we plug in numbers that are in between into the first derivative, that tells me if it's like climbing or falling, so I get a sense for what this graph is actually doing. So I'm betting on these are going to be positives and probably negatives. That's what I'm betting on because it went up and then back down again. That's what I'm betting on without even having plugging numbers in yet. Now, to get those plus and minus signs, let me get rid of that. To get this plus or minus sign here, you have to pick numbers in between.
This is the cont'd, right?
Yeah, so what we're going to do is we got to figure out numbers in between. I'm going to plug in 0 and maybe just the number like 2 here.
0 get you 0.
Yeah, so 0 gives me 0, which is still technically positive.
It's positive.
It's positive. It's technically positive. It's not negative. If you want to plug a different number like 0.2 in there, I don't really care. So if I plug a 0.2 in there, so 1 divided by, actually let me just, I'm going to go in parentheses 0.2 to the -2/3 power, and then -1. That's the first derivative.
Jamie,
Yeah, it ended up being positive.
First one.
So these end up being positive here. I plugged in some different numbers there, so it was positives.
Yeah, he just plugged it into the.
Yeah, that's for the in-betweeners.
The in-betweeners, you got to plug it into the slope one.
Oh, but the other one you gotta plug into the OG.
Yeah. Okay, so now I'm plugging the next number, and I actually get negative. So it was exactly what I thought it was
How
going to
do
do.
you plug that into a calculator?
What?
The in-betweeners?
Here, let me show you what I'm doing.
Next 3 options also got taken.
So here's the part that I'm doing right now.
So all 4 of my top 4, yeah.
So just putting it to the, I just used the first derivative as the -2/3.
First one I found.
Because it's easier.
Yeah, it was easier to type in.
Yeah.
That's just how I did it.
Alright.
What other ones did you try to pick?
So,
Something falling.
all right. All right, and so it was exactly what I thought. So this picture is doing something like this. That's pretty much what it's doing. It was a hilltop. Nothing fancy about it. So, okay, all right. But that's it for today. I'm going to turn you loose on your homework, or I should say your Google question of the day.